Hey, this is Adam with TechNet Edge. I am here with Nigel from HP. How are you, Nigel?
I'm good, thank you.
Good. Now, you just participated in a panel on green computing. How do you think the panel went overall?
I think it was a very good discussion. I mean, if you talk about green computing, you have very different aspects to it. So what are we doing as a company? What can people do in terms of reuse and recycling? And then the area that we really focus on is what can we do in our products to help you actually drive down power consumption in your data center. So I think, through the panel we had a very good discussion, and it was a good mix of people.
Okay, so tell me a little bit about that. What are some of the initiatives that HP is doing to make data centers greener?
Well, HP really works. We have a concept called chip to chiller, so we work everything from the component level through to what you can actually do in terms of data center design. So we partner very closely with the likes of Intel and AMD to leverage the work that they do to optimize their processes, and then we build that into energy optimized servers. So we take energy efficient memory, energy efficient processors, and then we do a lot of work around power supply design to then allow people to deploy a very energy efficient server. That's one aspect. You can then take it to a level above it where we focus on innovations like Blade System, and I think Blade System is very unique because it allows you to basically optimize or pool your power and cooling resources, and so typically you can save up to 30% in terms of power consumption just because you're sharing the resources. So those are kind of two areas. And then a lot of the discussion in the panel then was very much around, what can you do in terms of virtualization and consolidation? How can you basically use less servers, do more work with them, because that again will save power, all the way up to the way we can model and manage data centers to make sure that they have the right thermal blueprint. So for example, we can go into a data center, we can do an assessment of the heat and the cooling, hot and cold aisles, and then we can then work with the customer to optimize that.
Okay.
So all the way through the value chain.
One of the things that was interesting, I heard you mention around blade computing was the reuse of components, right? When it's time to upgrade, yeah. I don't have to throw out a whole box.
Well, it was an interesting question, and the thing today with us, if you buy a standard tower or rack mount server today, you are basically buying the processing capability, the memory, the disk. But in every server you buy, you are buying power supplies and fans, and so therefore when you upgrade the server, what you're effectively doing is you're throwing away those components and you're buying them again. So that can be very wasteful. Now, one of the benefits of Blade System is that first of all you are using less of those components because you are sharing them between the servers. But what it also means is you can invest in an infrastructure which may have a longer lifetime than the server, and then basically you can switch in and out the server components as those technologies change. So a server will typically, with the speed at which Intel and AMD come out with newer, faster generation processors, you may want to change the server more frequently, so you can change the server components but leave the infrastructure in place. The other thing that we're doing is that with the newer Blade System servers, the power supplies, for example, are now being standardized across models. So with that power supply, you will also be able to use it in future generations of servers. So what you actually move to is a system whereby a power supply can run in multiple machines and then can be reused, or it's much more efficient in terms of stocking of spares.
Okay, great. Thanks, Nigel. Hi, I'm here with Mike Manos. How are you, Mike?
Pretty good.
Okay. Now, we just sat in on the green computing panel discussion which you participated in. How do you think it went?
Oh, I think it was great. We had a tremendous amount of participation from the audience, and there was a good bit of good-natured jabbing across the panel as well. So it was hopefully it was good for everyone. It was definitely fun to be a part of as a participant.
Yeah. Now, you were there representing Microsoft and what we're doing with our data centers. Give us a little bit of an idea. What does our data center look like? How many are they? Where are they at? How many machines are we supporting?
Yeah, we have data centers literally all across the planet. We have hundreds of thousands of machines in our data centers supporting both our online initiatives and our internal IT support. And so, the idea of green and sustainability as it relates to that topic was pretty key for us. But we have a sizable footprint. We operate at challenges that most folks don't get to have.
Okay, so tell us a little bit about what you're doing to make those data centers green.
Oh, we're doing a bunch of different things. We're doing a lot of research. There's a team within my organization that is primarily focused just on driving innovation in the data center. If you think about the stuff in the data center, Moore's law has helped disk drives go from very low amounts of storage to very high. CPU processors, everything has kind of been affected by Moore's law. Everything except for the data center. And for the first time, we're starting to put some of our intellectual property and with partners to drive significant advances in the data center facility itself, along with advances in operating processes in the data center.
Okay. So tell us a little bit about that. Tell us, what the data center of the future is going to look like at Microsoft.
Takes no power. All the servers run on air. No. What it's going to do is it's really, we're trying to drive towards the ultimate efficiency in terms of maximizing work per watt. Right? You don't want to necessarily expend any more energy than you need to be able to deliver the services and the products online. And that's really our ultimate goal. There's a measurement in the industry called PUE, power utilization effectiveness. Some people call it power utilization efficiency. And our goal is in that metric, it's how much power is used for servers and equipment and work versus how much power is used to cool it and all the back of the house components. Right? We want to maximize so that every last drop of energy is being used for actual work and productive work, hopefully work that furthers our services products.
Okay. There was a comment that you made during the panel about one of the reasons that we chose San Antonio as a data center. Can you talk a little bit about that?
Sure. Well, we actually use over 30 different factors in site selecting our data centers. And one of the things for the San Antonio facility, which is the one that you mentioned, was the availability of recycled water. Data centers consume lots of water, and so if you can find an application where you use recycled or gray water in support of that facility, you're not taking water out of the municipal system. You're not taking water out of the aquifer to impact the local environment. So it's a good reuse of that power, reuse of that water resource for the data center, and it has the pragmatic benefit of costing lower, having a lower cost than just drinking water or taking water out of the municipal supply.
Okay. Is one of the factors that you consider also the source of power?
Yes, across those 30-odd factors, we look at a bunch of different things like power capacity, power reliability, power cost, and power generation and makeup of that power. How much of that power is sourced through high sulfur coal burning versus wind energy or solar energy, and it's a primary factor in terms of how we look to place our data centers across the planet, not just domestically in the United States, but really all over the planet.
Okay, great. Thanks, Mike.
Thank you very much.
Right.
And it's my
Manos, M-A-N-O-S.
Manos, hands. Okay. I'm here with my good friend Mike Manos.
Yes! So close. Yeah, that looks
Okay.
a lot better. Okay, cool.
All right, you're framing from, okay.
I'm framing
Okay,
okay.
How about, do we open up or
Oh,
facing
no.
a little bit? This is better? Okay.
Yeah, this is cool.